This presentation is on the subject of the formation of spiral galaxies. In the presentation on the galaxy distribution, the progression of galaxy formation suggested that there was a way in which galaxies formed, and in this example, we see two spherical galaxies forming in the first instance with a separation of 2 million light years. And we're going to examine what would happen over time to the shape and movement of these two spherical galaxies under the effect of the expansion of space and the acceleration due to gravity between these two spherical regions. Now, what you find is that for this galaxy, the gravitational attraction is towards the center of mass of this galaxy. But the attraction from this side of the spherical region and this side of the spherical region, because of the difference in distance, have different characteristics. Now, we noted from the formation of galaxies that there is a tendency for galaxies to form in a progressive way. So in the first 14 billion years, we get 20 galaxies. And subsequently, every 14 billion years, we get the number of galaxies increasing by a factor of 20. But the position of galaxy formation is significant. And it seems that there is a tendency for galaxies to form within or in the region of 2 million light years apart. Now, what this is a simulation of what would happen to a spherical region affected by the expansion of space. So this region of dots started off at the outer regions of the spherical surface. And after 5.3 billion years, the tidal effect has extended into the spherical region into a form of ellipse. After 6.8 billion years, it's stretched even more. And after 14.8 billion years, you can see that these parts of the spherical shape have merged with the other part of the galaxy. So this then represents the spiral arm after 20 billion years. It's extended to this sort of position. So to illustrate the point, you can see that the spherical regions started off symmetrically in a spherical shape, and under the movement due to the expansion of space and the gravitational attraction, they become ellipses. And so you could ask the question, why didn't these two galaxies merge head on? Because for the galaxies to be rotating, they must have approached at not quite a head-on merger. because by the time they start to merge, some formation of a black hole in the central region would have taken place. But if we think of these galaxies in relation to the center of the universe, there will be a slight gravitational acceleration, which is different in the case of the two galaxies. So I think that would be the explanation why they didn't merge head on. So what then happens is that the two galaxies merge, and the remote ends of the ellipse become the tails of the spiral arm. And this then is an illustration of the merged galaxy. But you can see that this process takes at least 20 billion years to complete. So it tells us that the effects that we see, the spiral galaxies, take a lot longer to form than 13.8 billion years. So the conclusion is that all spiral galaxies formed from two spherical galaxies, which formed approximately 2 million light years apart. And this accounts for the angular momentum, which is key to understanding why the galaxy is rotating, why the black holes are rotating, and the formation of the solar system required angular momentum, and that came from the merger of two galaxies to form the Milky Way galaxy. And this process clearly takes a lot longer than 13.8 billion years. And it's merging galaxies that leads to star formation in the areas where the gas and dust becomes compressed, leading to the regions to form stars. So that concludes the presentation on the formation of spiral galaxies.